Hello and welcome to today's webinar, an introduction to vSphere with Tanzu, the VMware hands-on lab. This event is presented in partnership with VMware and produced by Actual Tech Media. Thanks so much for joining us on this special webinar. This is going to be a little different from many of the webinars we do. That's because this webinar is going to be specifically focused on how to use VMware vSphere with Tanzu as seen and taught through the VMware Hands-On Labs. If you're not familiar with VMware Hands-On Labs, you can go to the link that you see right there at the top of your Handouts tab, and you can follow along with everything that you see in this event in your own web browser for free. So make sure that you try out vSphere with Tanzu for yourself. Now, before we get started and I introduce you to today's expert presenter, there's just a few things that you should know about the event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. We want this to be an educational event, and we encourage your questions in the questions pane. We'll be answering all of your questions live at the end of the demonstration, so make sure that you get your questions in early. And to help encourage your questions, we also have our Best Question Prize, which I'll talk about here in just a moment. I also want to call your attention to the Handouts tab. It's there that, as I said, you'll find a link to follow along with everything that you see in this lab for yourself in your own web browser. There's also a number of other links and resources available for download, specifically an ebook on vSphere with Tanzu and everything that it can do for you, as well as the full hands-on lab guide that you can use to download and follow along. At the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card, so make sure that you stay tuned for that. All prize winners must, of course, meet the Actual Tech Media prize policy that you'll find in the Handouts tab. If you're watching this on demand, the drawing has already occurred. We also have our Best Question prize for an Amazon $50 gift card. We'll select the winner of this prize after the event and contact them via email. And that just shows how much we value your questions. So with that, it's time to kick off today's special event. I'm excited to welcome Mr. Bob Bauer, Staff System Engineer at VMware. Bob, it's great to have you on. I'll hand it off to you. Take it away.
All right. Hello, everybody. Thanks for joining us today. My name is Bob Bauer, and we're going to be covering vSphere with Tanzu, and specifically the hands-on lab that we create around this for VMworld. So again, my name is Bob Bauer. I'm a staff SE on the Modern Applications Business Unit team. So we're the team that deals with all of the Tanzu products. Tanzu is really a portfolio of modern application products. So it's not just the Kubernetes piece that we're going to be looking at today, but there are other pieces. So I'd encourage you to go look that up. I'm a lab captain and one of the co-creators of this hands-on lab, and we'll be refreshing this for VMworld 2021 as well. So there'll be a new version of this coming out in a couple of months. I come from a background in large enterprise networking, and vSphere operations. So I worked for a couple of very large enterprises operating their production vSphere environments. Also have a background in cloud networking and NSX and cloud architecture. And I live in Minneapolis. So I'm happy to be with you guys here today to talk about this hands-on lab. Some people are interested in how we put these things together. So this particular lab is rather large. We use a vCloud Director, and we run on a number of different public clouds. We use up to 5 different public clouds to present these hands-on labs. This particular lab has a number of what we call layer 1 VMs, which are running in the base virtualization layer, so you don't see them in the lab. And then we also run a number of layer 2 VMs. So this one has 9 different virtual machines that make up this hands-on lab. Well, 51 vCPUs, 164 gigs of memory, and 867 gigs of disk. So it's a very sizable lab. And you can imagine when we deploy this at scale, the amount of resources it takes to run this. So it's just a little bit of background. You can see there's some different networking constructs in here where we have various networks exposed out to the VMs. And then everything is sitting underneath on a base network that's on our virtualization layer. And then we use a virtual router to network all of that together. So what we're going to go through today, I'm not going to step through every single piece of the lab, but we're going to cover the modules and kind of show you, pick out areas of interest to dig a little deeper into, and just kind of show you around hands-on lab in general and how to navigate the HOL 2113, which is vSphere with Tanzu. So the first module is really mainly an introduction. We talk about some of the principles behind Tanzu and some of the Tanzu services that get exposed. And then there's an interactive simulation, or what we call an iSim, that goes through what it would be like to actually enable this in your vCenter. And so that's a click-through module that we won't really click it through here, but what we'll do is we'll just show you a little bit about what that is. And we'll spend more time in Module 2 and Module 3. So Module 2 is really around the VI admin persona. And it's all about managing, in Tanzu itself inside of vCenter and some of the components in there and what you would do during that workflow. And then Module 3 is something that would be a little bit more developer focused. So if we have, a mix of VI admins and developers in the audience, there's something for everybody here. And we'll go through really working with Tanzu Kubernetes clusters, explain those and what the basic operations around logging in and deploying an application or a cluster. So with that, I'm going to go ahead and switch over and get started with the hands-on lab. So this is the hands-on lab regular interface. And so this just is where you go to get started. And if you go to try our labs, it'll bring you to the catalog, and then you can search for just 2113, which is our Tanzu one, or you could search for Tanzu and it'll bring up all the ones that match it. And you'll notice there's a lightning lab. That's kind of a slimmed down version that just picks a couple pieces of the larger lab and allows you to move through it really quickly. And then we have our vSphere with Tanzu, which is the lab we're going to go through today. And so I've already got this up and running, so I'm going to just resume this lab. When you click on it, it'll bring it up and drop you into the lab environment. And you'll notice that it pulls up a guide over here that has all of the kind of guidance on how to work it, as well as a table of contents and working through the whole lab. And then what you'll get in the other window is actually like a console to our virtual machine. So for those of you that haven't done hands-on labs before, we'll just spend a couple seconds on orientating you on the interface itself. There's controls up here that allow you to change the size of the screen and toggle full screen and things like that. So you can click on that or click on this to maximize your console desktop. And one of the things you always want to look for when you're doing hands-on labs is to look to see that this is ready. So for those of you in the room that might be following along, we can pre-populate some of these labs, but then we get to a point where we're having to spin them up on demand. And so this lab status can take a while to go green as the various machines are spinning up that I showed in that diagram. And as we kind of work through getting all those connections verified and validated. So it's not uncommon to see, an initializing down here where this is red. So just make sure if you are following along that you wait for this to go green and ready before you try to do any of this. Otherwise, you'll run into all kinds of errors. The other side of the interface is your manual. And so you can actually pop this out into a floating window. You can step through it here. You'll notice that there's an arrow navigation here as well. So you can use this to work your way through the lab manual. And so we'll spend a little bit of time on there. And then this is basically just a virtual desktop. So you guys are all familiar with this, I'm sure. And if you pop out the table of contents, it'll show you the modules that we talked about. And so the way that hands-on labs are built is allows you to jump around and start any module in any order. So they're not predicated on you finishing module 1 before you go to module 2. So that allows you to come back and do these at any time. So if you do some things today and then you go home and want to jump back in, you can feel free to jump back into any of these modules. So the first one we're going to talk about is module 1. I'm not going to spend a lot of time in here. You can click down and go to the introduction. You can see it. It will bring you to the specific area over here. So you can close this and it will bring focus into your manual. And you can blow these manuals out to make them larger if you want. But the first section module is really a lot of introductory items around, what is Tanzu, the theory behind it, what components and services are brought in. So I'm not going to spend a lot of time jumping through this. There's a couple of videos in here that talk a little bit about more the networking underneath Tanzu. And then the services that we expose, meaning the ability to provision Kubernetes clusters, using your existing storage for persistent storage in Kubernetes, those types of things. So there's a lot of reading in here that you can go through that will really kind of orientate you within the service. The other piece I did mention is this hands-on lab interactive simulation. And so if we click to that item and we scroll through here, you would be able to click here to open the interactive simulation. Again, I'm not going to really spend a lot of time on this here because this is something you can run through. But iSim is basically a clickable interface that takes you step by step through what it would be like to enable workload management or Tanzu on your vCenter. So if you want to run through this at in your own time, it's a good thing to do. Kind of takes you through what it would be like to turn it on. That's a process that takes a lot of resources and is a bit time consuming. So we don't have you do it live in the lab, but this will give you a feel for exactly what it's like. So I'd encourage you to go back and look at that when you have time. Now, the next piece we'll run to, and this is where we'll spend quite a bit more time, is managing vSphere with Tanzu. Again, this whole lab is about 90 minutes, so I'm not going to walk you through every single step and every single screen. What I'm going to try to do is give you an idea how to work through the lab and then kind of drill into on things that are of interest. And one of them is, we talk about the supervisor cluster. We'll talk about what that is. But again, if you follow through this while we're going through the lab, you'll be able to read these up or read them at a different point in time. It talks about the supervisor cluster. So instead of walking through this, I'm actually going to jump into vCenter and talk you through it there. But just know that you can use this module guide and this table of contents to circle through and do any of the things that we're talking about. So we'll open Chrome and we'll get logged into vCenter. This does have the credentials saved, so sometimes you have to just kind of hover over the login button until it goes blue for you, and then you can click on it to log in. And this will dump us right into our vCenter. And I'm going to go ahead and close the manual so we have a little more real estate. And I'm going to close this bar down at the bottom as well so we have a little bit more. But what we're looking at now is vCenter. This is what you're used to seeing as a VI admin for those of you that are in that role. And when we talk about enabling vSphere with Tanzu, this is done on a per vSphere cluster basis. So if I have multiple clusters in here, I can choose which clusters I enable the Kubernetes service on, and I don't have to do it across the board. It is a per vSphere cluster construct. And what you'll see in the iSim is we go up into this workload management when we're highlighted on a cluster, and this is where we can actually enable it. So what I see here is I already have one cluster that's enabled for it. It gives me some information about this cluster, what is the control plane IP address and things like that. And then there's some other operations that you could do up here around patching and things like that. So we're not going to cover enabling, but what happens when you enable is we will create this object, this namespaces object. And for those of you, again, familiar with vSphere, you'll notice looks like a resource pool because it really is. And this namespaces resource pool is the place that we use to basically house all of the Tanzu Kubernetes objects. So we'll go through all of these one by one, but when we do an enablement, what happens is we create this and then we deploy 3 virtual machines that we call supervisor control plane VMs. These supervisor control plane VMs are really the management cluster for Kubernetes running on this vSphere cluster. So this is a management component, and it's part of the entire cluster API construct. And so I don't expect most of you have experience with cluster API, but I would encourage you to read it up on it. But what we're doing with vSphere with Tanzu is we're using cluster API and Kubernetes to allow you to do all the lifecycle management of Kubernetes in your organizations. So Cluster API is an upstream Kubernetes project. There's a lot of large vendors that are part of the Cluster API project. And it's all about using Kubernetes to manage Kubernetes, the same way that you use it to manage your applications. So by using Cluster API in conjunction with our Kubernetes supervisor cluster, we allow you very simple and powerful management of all your Kubernetes deployments within your organization. So it's lifecycle management. It's creating new Kubernetes clusters. It's patching existing clusters. It's scaling clusters. So it's using Kubernetes to do all of the same things you do for applications, but to actually lifecycle manage the rest of the Kubernetes clusters in your organization. So we'll dig a little bit into this, but what happens when we enable Tanzu with Kubernetes on vSphere 7 is we create this namespace object, we deploy these virtual machines, and we deploy operators on this supervisor cluster, which is a cluster running on VMs with all of our custom operators and the cluster API operators installed. And then this becomes the way that you create the rest of your Kubernetes clusters. And so we'll go through that in module 3. As an administrator, then the next object that you will be interested in is something that's called a supervisor cluster namespace. And it is a Kubernetes namespace. Those of you that are familiar with namespaces know that it's really a way to determine who can see what and what they can do and what they can use. And so we use that the same way within vSphere 7 with Kubernetes and Tanzu. We created a supervisor cluster namespace as really a way to contain Tanzu Kubernetes grid clusters and provide permissions into those clusters and determine what kind of storage they can use, how much compute and memory they can use, and view all of the objects that are in there. So you can think of a supervisor namespace as kind of a virtual tenant that you would create in your Kubernetes environment that you can hand out to teams. So you can use namespaces to manage different line of businesses or different applications or different teams and provide access in to leverage Kubernetes. So the namespace object is really, again, something that a VI admin would create. And so module 2 takes us through kind of step by step. First of all, what do you all see within a namespace and what is it? And then have you create one. So what we're going to do is we're going to cover a few of the things that you can see inside of it. Again, I'm not going to jump down into every little bit because there's a lot in here that would take longer than we have time for. But again, as I mentioned, a namespace is a way to really kind of create a virtual tenancy within your Kubernetes environment. So when you create one, some of the things you do is you assign permissions. So who can see and use this namespace when they're talking to Kubernetes? When I create storage, things like persistent volume claims is what Kubernetes applications use to store their stateful information. What storage policies do I want to enable within this namespace? So this can use any of the underlying storage that is inside your existing ESXi clusters to also store persistent volume claims for Kubernetes workloads. So you don't have to figure out something different for storage with Kubernetes. We leverage what you already have today inside your vCenter to do that. You can also set limits on capacity and usage. So one of the things that Tanzu does, and you'll see this as we move into module 3, is allow you to do self-service of Kubernetes clusters for your development or your SRE teams. Meaning, once the supervisor cluster is set up and once you've created a supervisor cluster namespace for a team and given that team access, you can actually allow them to create and manage their own Kubernetes clusters. So that's not something that the administrative team needs to take on as a role anymore. That can actually be turned over to development or can be turned over to automation to do. But you can put guardrails around how much of the capacity of this cluster they can consume and where does their storage end up and who can see it and what can they do. So what it really does is it gives you the ability to enable basically a Kubernetes dial tone or Kubernetes as a service within vCenter, and then allow other teams to really consume that without having to get involved with that yourself. But the great thing about the way that you see this in vCenter is you actually have a lot of visibility into what's happening within these namespaces. So this demo app 1 is a namespace that we pre-created for you. And we set permissions, in this case, just to allow the administrative user to be able to edit the namespace, which means they can create new clusters in there. They can see everything that's in there. So they'll be able to create new Tanzu Kubernetes grid clusters. They'll be able to see other clusters that are in there. We've set a persistent volume claim storage policy to use something, a storage policy we created called Kubernetes. Again, this is just a normal vCenter storage policy that gets configured. It's nothing different. It's basically pointing to existing data stores and storage that is compatible underneath vSphere. And we're just basically saying, this is where we want our storage to end up when we create something inside this namespace. And then in this case, we didn't set any limits, but you can edit these limits. You can see that you have the capability to set CPU, memory, and storage on this particular supervisor cluster namespace. So although I would potentially turn over self-service either to some sort of automation or CI/CD tooling, or even developers using the kubectl command line to create clusters, I still have the ability to control how much of my cluster capacity can be used by this namespace. And then finally here, you see that we already have a Tanzu Kubernetes Grid cluster deployed in here. And we'll talk about those in a couple minutes. But the point of this is, as a vSphere admin, you have a lot of control over what can happen within these namespaces, as well as a lot of visibility. So you can see the events that go on. And so the hands-on lab module 2 walks you through a lot of these screens, and it will take you in depth into the resource limits and the general configuration items that you can have in here, the permissions, looking at the compute tab. You can see the Tanzu Kubernetes Grid clusters that are already created in here. You can see the virtual machines that are created that back those up, and information as to what class of VMs they're using. You can see the storage policies that are enabled within this namespace. If there's any volumes that are already deployed, you can see them in here. And then you can see some of the networking information. So again, as an administrator, you have a lot of control. There's a lot of guardrails and knobs that you can twist to help make sure that even though you may allow self-service, you can protect your infrastructure from being overused. So the next thing that the hands-on lab does is it will go through, and I'll pop out this manual. So we've kind of gone through a couple of these pages about logging into vCenter, expanding the cluster, looking at the supervisor cluster VMs. So you can read those in your own time. It'll talk a little bit about how they get provisioned and some of the details around them. And then we talked about the namespaces. So we've kind of gone through this area where we've talked about the demo app 1 namespace, what it shows you, all the information you can get as administrator, and the configure tabs and those types of things. And then the next thing would be to go through and actually create one. So I will get to this one where we can actually create a new supervisor cluster namespace. And again, this is something that as a virtual admin would be something that would be in your job description. What I show here is there's a couple different ways you can do it. And I always like to show customers that there are a lot of different ways to create a supervisor cluster namespace. One way to do it very easily is just to right click on the vSphere cluster object itself, and you'll see there's a new namespace tab here. The other way is you can see when I'm highlighted on this, there's some new categories that weren't here before if you aren't using vSphere or Tanzu, namely this namespaces tab. And so if I click here, I'm also able to create a new namespace. And then the third way is going up into workload management and creating a new namespace here as well. There's some reasons why they created all these different ways to do it, is because only members of the administrator at vSphere local are going to see this namespace tree in this view. If you're logged into vCenter as an administrator, but you're not a member of the administrators at vSphere local group, you wouldn't see this namespace object and these types of things. So then your workflow would be working through the namespaces tab here or up here. They all get you to the same place. So it talks about in the lab, show you the different ways you can create it, go through and create namespace, create new namespace. It has you select the vSphere cluster. As I mentioned, there can be multiple vSphere clusters that have Tanzu enabled. So you may have more than one choice. So it has you go through and pick our region A, which is our only option here, and then click in and type the name of the namespace. So in our lab, we did demo app 2. You'll see a little a note here that says basically needs to be a DNS compliant name. What that means is it needs to be lowercase, only certain characters are supported, things like a dash. It can't start in a capital letter. It has to be basically numbers and letters, all lowercase. And so if you did something different, you would see that error pop up here. So that's all that it means there. It doesn't mean it actually needs to be a DNS entry somewhere. It just tells us it needs to be in the format that is compliant with DNS. And then networking here would allow you to choose from what we call the workload network. So this is where the virtual machines that your TKG clusters are created from would be attached to. And then we go ahead and hit create. And so no matter which way you go, it dumps you into this same wizard. So the rest of the lab will walk you through some of the things that you want to set. And there's also this handy little tip that comes that says, hey, before you go out and share this with a DevOps team, you might want to do these following things. And so you can dismiss this wizard. What it's basically telling you is you want to be able to do things like add permissions. Now, one of the cool things that we're doing with vSphere with Tanzu when it's part of vCenter 7 is we're exposing any of the identity sources that you have linked to vCenter already as an identity source. So we're actually taking on authentication for Kubernetes, which can be challenging to configure on your own. And so you'll see here we have the normal local OS and vSphere domain, and then we have a corp.local, which is an Active Directory identity source that's configured into this particular vCenter. So again, any identity source that is supported under vCenter can be leveraged as an identity source to authenticate users into the namespaces and the TKG clusters that sit underneath it. And then I'm just going to go ahead and just start typing something. I type a user, I can type the name of a user or a group, and then I'm going to select a role. And I'm going to choose edit here. And it does talk about the roles a little bit in some of the documentation. But basically right now today, there's an edit and a view role that's supported. The edit role really gives you the ability to create Tanzu Kubernetes grid clusters within this supervisor cluster namespace. And again, we'll cover that in module 3. If you're a view, it's read only to the namespace, which means you can see any Tanzu Kubernetes grid clusters that get created underneath here, but you can't create your own. And then we will authenticate you to the Tanzu Kubernetes grid cluster, but we can use custom role binding within Kubernetes to map that to any custom role or any of the built-in roles that Kubernetes has. So it gives you a flexible way to allow us to authenticate you, but control which role you would have on the Kubernetes clusters. Whereas if you are an edit user, you will automatically be mapped as a cluster admin to any Tanzu Kubernetes grid clusters that are created underneath this supervisor cluster namespace. For those of you that aren't Kubernetes, really deep into Kubernetes or don't understand all the pieces yet, don't worry about it. You'll understand that as it goes, but Kubernetes has its own RBAC built into it where you can create roles that say what you can do in the cluster. We're going to authenticate and then either have you automatically map to the cluster admin or allow your Kubernetes teams to map you to a custom role. That is how you might operate your organization. So you can add multiple different groups, individual users in these two permission categories. The next piece would be around adding storage. And so the storage policies, again, these are just standard vSphere storage policies. And they map to backend storage. So that can be vSAN, that can be NFS, that can be block storage on a SAN. Whatever storage is on the HCL for vSphere is supported to be used for these storage policies. And again, it allows me to create where I want to have my persistent volume claims for Kubernetes clusters and the VMs that get created for the Kubernetes clusters live. And I can set more than one. And so you can use different tiers of storage for different applications and things like that. And then we talk here about creating limits. So here, editing limits, I can set these limits and it talks about, setting a 5 gigahertz limit on CPU. I think, what do we do? 4 gigs for memory. Now this would be very small, so this wouldn't work really well for a cluster. And then storage, 5 gigs for storage. So this just gives you an idea how you can actually set these resource limits on these. And then finally, it will show you if there's any clusters already there. And then there's a piece here about content libraries. So we'll get into this a little bit when we also configure Tanzu Kubernetes grid cluster and go through that. But in the instructions, it talks about what we do with the content libraries, and it takes you through actually viewing the content library that's already there. So the way that we distribute the OVAs for the virtual machines that make up our Tanzu Kubernetes grid clusters is through a content library. Now, in a normal environment, this is actually a subscribed content library that goes out and talks to a CDN in that VMware hosts, and we regularly publish new versions of these OVAs. And these are standard OVAs that have all of the components required to deploy a Kubernetes cluster. So it's the operating system. Currently, we have Photon as our operating system, and then it's the version of Kubernetes that we're running. So now this lab was made, several months ago, back in, I think the last time we published it was before VMworld in 2020. So we've actually, had numerous different versions of Kubernetes come out since then. We're, supporting up to 120 currently, but it has the different versions. So what you would see in an environment that had internet access, you would see a number of different options for versions of Kubernetes that your developers or your infrastructure folks could deploy to create a Kubernetes clusters. And so a lot of times application teams will have tested on a certain version of Kubernetes for their application. And so they may want to have control of that. Having this content library with lots of different versions available to them, again, gives them the freedom to kind of support the version of Kubernetes that they want for their application and that they need for their application. And it's done via having multiple OVAs that are sitting here ready to deploy any one of those versions. Now in this lab, because this is an internet isolated environment, we only have this current version of 118 up here. But again, in a real environment where this was a subscribed library, you would have a bunch of different options. If you are running air-gapped, you can manually pull down these OVAs and push them into vSphere to still give your developers and your SRE teams and whoever's deploying your clusters the same experience without having internet access. But if you do allow it to pull from the internet, these will just continue to add new versions as we publish them. So when we talk about content libraries and where do we get the VMs to actually create our Tanzu Kubernetes grid clusters that we're going to do in module 3, this is where it comes from. And so when we were going through setting the permissions and the configuration of this, one of the items are this content library that you could edit. So you could have different content libraries for different supervisor cluster namespaces if that was something that you needed to do. Okay, and so that's mainly what module 2 covers is again, things that are done inside of vCenter that are more of a VI admin type of role. One thing I didn't talk about is within this existing namespace that we had deployed when we started this, is we did have a Tanzu Kubernetes grid cluster. And so when I look underneath the namespace, I actually see this different object, and it is a Tanzu Kubernetes grid cluster. It lists itself as developer managed infrastructure. Again, that's the whole premise around being able to self-service deploy these objects. And if I expand it out, what I'm actually going to see are the virtual machines that make up a Tanzu Kubernetes grid cluster. So these VMs are really just normal virtual machines. They've been deployed from the OVAs that we just looked at that are in the content library. And so it is a Tanzu Kubernetes grid cluster running on virtual machines inside a namespace that we've configured on our supervisor cluster. So that can be a little confusing at first, and we'll kind of dig into that to the next module where we talk about this. But again, if you look at the namespaces, you can see a lot of this stuff. And again, so we looked at these Tanzu Kubernetes grid clusters here. If I wanted to compute, I would see the same kind of view I saw. I have one cluster. If I look at the virtual machines, it shows me the virtual machines. It's basically the same thing that I see underneath here. The other thing I want to touch on before we move on to module 3 is that we talk a lot about self-service with Tanzu Kubernetes Grid and allowing your development teams or SRI teams to create their own Kubernetes clusters. By no means does that mean that they're logging into vCenter and accessing any of these things. What I've showed you in the module 2 is all about what do VI admins see inside of vCenter and what do they create to enable this self-service. Developers and any other automation that's going to want to consume this Kubernetes dial tone to create Kubernetes clusters for your applications is going to be doing that through the Kubernetes API. So again, this is kind of where, if you're not super familiar with Kubernetes, it's a concept that you'll have to do a little bit of reading up on, but Kubernetes has an API that it publishes, and developers interact with that API through the kubectl CLI. It's a command line tool. They log into it, they have rights to talk to a cluster, and they request objects to create their applications. And that's a real oversimplified view of what happens. But all of the developer workflow, all of the self-service consumption that they would do is done through the Kubernetes API server. None of it is done through talking to vCenter. So we're not giving people access into vCenter. When I give somebody permissions into a namespace object, that's not a vCenter permission. That's a Kubernetes permission. So they wouldn't be able to log into vCenter, nor do they have any reason to log into vCenter to do any of this stuff. So I just want to kind of strike on that, because sometimes, that is always a concern of the VI admin is who's in my vCenter. How do I manage these positions? How do I make sure they're not doing things they're not supposed to? So again, none of this that we're going to be talking about in the next module is actually done through vCenter itself. So now we'll move on to module 3. And module 3 is all around working with Tanzu Kubernetes clusters. And so there's an introduction in here that talks about what is a Tanzu Kubernetes cluster. So what we covered in module 2, again, was enabling this Tanzu Kubernetes grid service on this vSphere cluster so that we have this capability and this capacity to deploy Tanzu Kubernetes grid clusters. And these Tanzu Kubernetes grid clusters are virtual machines running Kubernetes. This is where all of your applications are going to run. This is where your developers are going to work. They're not going to work up in the Supervisor cluster. That's really a container and a permission model and a tenancy model that helps you manage all of these objects as you create it. But the developers, at the end of the day, all of their stuff is really going to be running on these TKG clusters. So this would be the same as going out and creating a bunch of VMs, downloading kubeadm and kubelet and the kubectl, manually creating the cluster and turning it into a Kubernetes cluster, except that all of that is automated by Cluster API. And we're automatically leveraging consumption of the storage that's underneath vSphere and the networking configuration that's under vSphere to make this workload work. So it's an easy way to drive all of this workflow. We didn't spend a bunch of time talking about the networking, and I'm not going to spend any more other than just say that we support HA proxy, NSXT, and as of U2, Avi load balancer, or what's now called the NSX advanced load balancer, to provide that network function that we'll look at. So there's a couple options for how you do it. This particular lab, because it was built on U1, is using HA proxy. When we rebuild the next version for VMworld, it will be on the newer version using Avi, which is now again called the NSX Advanced Load Balancer. Okay, so section 3, module 3 takes us into kind of more of a developer-centric workflow, and again talks about creating a Kubernetes cluster. So Tanzu Kubernetes Grid, it's an open source upstream compliant Kubernetes that VMware distributes. So we're not forking Kubernetes, we're actually taking the upstream open source, we're adding our controllers and some of our secret sauce to it, and we're making that available to you. So this is an upstream open source compliant Kubernetes that your developers will be very familiar with. This area covers a little bit of the stuff that we've already covered into, which is going through some of the stuff in vCenter. But as a developer now, really most of my work is going to be done at the CLI. So at the Kubernetes or the kubectl command line. So I'm going to make this larger so it's a little bit easier to see. And for those of you, again, that are not necessarily real familiar with Kubernetes, this may be a little bit confusing, but it does a good job of spelling it out in the lab. So what I go through here, you'll be able to get more information into the lab itself. One of the cool things about Hands-On Lab is we do show commands that you can drag and drop over into your window so you don't have to type them. One other thing I'm going to show real quick is how do we get this IP address? So we're going to now log into this Kubernetes cluster that we created. And we're using the Kubernetes command line, or the kubectl is what most people call it. And we're going to authenticate to our supervisor cluster so we can now start to do stuff. And this, again, is something your developers would do. Every time you enable Tanzu Kubernetes Grid in a cluster, you're going to get a load balanced IP that is either provided by Avi or NSX or HA proxy that load balances the Kubernetes on that particular cluster. And so your developers, when you go to onboard them, what you can actually do is just hand off this IP address that shows up for this cluster. Oh, I think I have to put HTTP in front of it, or PS. And what we do is we host a web page on this particular supervisor cluster. So each Tanzu cluster that we enable will have its own supervisor cluster and a different IP address. So if you have people that are on different ones, they might be different. But this landing page is a great place to kind of hand off to your development team. So they can download the kubectl command line as well as our vSphere plugin, which we use to do authentication. And you can see that we have it for Linux, Mac, and Windows. So your developers could simply download that onto their jump box or their work box, wherever they're doing their work. And then they would be able to authenticate into the supervisor cluster and begin to do things. So this talks about how you log into it. I'm not going to spend a lot of time on it because it's better to read it. But basically, if you're doing the lab, you can actually highlight that, drag this command over and drop it into your shell. And HOL will automatically populate this information for you. So you can see what I'm doing is I'm logging into that same IP address I had up here, that 129. That's my supervisor cluster API for Kubernetes. And I'm using the administrator corp.local username. And I'm using this kubectl vSphere login. So this is what allows us to use our SSO to actually authenticate you to Kubernetes. And so I'll go ahead and type the password, hopefully correctly. And we'll log in. And what happens is now I get to see what I have access to. So we automatically surface which areas I have access to. In Kubernetes, these are called contexts. You can think about it as setting the context for your kubectl CLI tool, which cluster or which namespace I want to talk to. So we'll see that I have a context that is my supervisor cluster, which is the thing we just logged into. As a user, I don't really have the ability to do anything on there. And if I try, I'll get permission errors. And then you'll see that I have two namespaces that I've been given access to, the demo app 1 and the demo app 2. And so the lab will take you through and explain setting a context. Again, what it's really all about doing is setting the context for your kubectl, which cluster or namespace am I looking? So we're going to set into the demo app 01 context, which is looking at this demo app 01 namespace that we created in the supervisor cluster. And I have the rights of edit on here. So now I could go and start creating stuff. I can start creating my Tkg clusters. Now the lab doesn't go through all of these commands. So I'm going to just show you guys a couple things before we move into this part. There are, and if you want to explore the kubectl, and you can do this in the hands-on lab, even though it's not in the instructions, this is a full environment. So you can basically explore and do stuff that's a little bit off book. Not everything's going to work because you might not have the rights or we might run out of resources, but I'm just going to show you one. So if you type the kubectl API resources, what it's going to do is show you all of the resources that this Kubernetes cluster can look at. So what these resources are is what the Kubernetes API understands and knows as resources. Some of these are built-in Kubernetes objects. Some of these objects are ones that we provide through our VM operators. If you remember on our supervisor cluster, I said we install a bunch of operators that extend the functionality of Kubernetes to work with our stuff and to do cluster API stuff. And so you'll notice some of the things that come are part of the upstream Kubernetes. Some are part of our Tanzu or VMware operator pieces. But if you're ever looking for in any Kubernetes cluster, what commands do I have access to? This API resource is a good one. And so the one I want to look at is we want to look at these Tanzu Kubernetes grid clusters. If you remember, I said this is where your developers work. So as a developer, I could look and say, hey, show me all the Tanzu Kubernetes grid clusters in all the namespaces that I have access to that are out here. And it shows me I have that Tkg Cluster 1. It's in the demo app 1 namespace. This matches exactly what I would see back in vCenter as a vCenter admin. So if I go back to my hosts and clusters and look at this, you can see I've got that same cluster object here. And I'm not going to spend a ton of time digging deep into cluster API because this can get over your head very quickly. But there's a couple other things I can notice that I can look at. So I can look at something called get a VM. So I can kind of do that same command I just did. Instead of looking at tons of Kubernetes cluster, I can look at a VM. It actually shows me the workers, the VMs that are backing up this particular cluster. So again, same thing I could see in vSphere as a vSphere admin. The VMs, I can actually see them as a developer. And as I get familiar with Cluster API, this becomes really powerful because they can see all of the things that make up a Kubernetes cluster running on virtual machines as Kubernetes objects. And that's really the magic of Cluster API, is it holds these objects that represent something. Now, these VMs aren't actually running inside this namespace. They're running in vCenter just like anything else, but the objects that represent them are part of this namespace. And as a developer, this becomes very familiar to me because it's the same things I would see when looking at an app. So I can look at things like, the deployment behind it. I can look at what's called a machine set, which is similar to, a deployment. I can look at a machine deployment, like replica sets. I can look at machines that are behind it. So this is very familiar to your development and your SRE teams that build your clusters. And if you're going to take this job on, they'll become really familiar to you as well. You have all of this power inside of the kubectl and the Kubernetes API to do all of this lifecycle management of Kubernetes clusters. So if we go through the lab, what it wants us to do is change into this directory. So this jump box has a directory, a bunch of different files in it. And one of them is, what is it like to create a Tanzu cluster? So I keep talking about this self-service and what this like, and that may feel like you have to build a lot of automation around it, and it's very difficult. But in reality, I'll just list this Tkg Cluster YAML file. So your development teams, to deploy their own fully functioning Kubernetes cluster that's complete, has authentication built in, it creates the virtual machines behind it. All of the network has the ability to create network entries and services and use persistent storage. They're all created by this very short YAML file. So this is maybe 15, 16 lines. And this would be done just like you would any application. kubectl apply -f to this file. This is how we created this Tanzu Kubernetes grid cluster that we were just looking at. So we get to say what version of Kubernetes we want to run. We get to talk about, so that's right here, 118.5, how many master VMs, so the control plane for Kubernetes, what size VMs those are, how many workers, what size VMs those are, what network stack I'm going to use, Antria or Calico, what IPs I might want within the cluster, and then which storage classes can I use. And from this very simple file, we will create the virtual machines, install Kubernetes, turn it into a cluster, and return you a fully formed Kubernetes cluster in maybe 10 to 15 minutes. And if I wanted to add additional nodes, I could just scale this cluster up and add more workers through a very single command. If I want to upgrade to the next version of Kubernetes, I can do that from a single command at the command line. So this puts all of this in full self-service for your development teams and your SREs, or if you want to use something like vRealize automation to create clusters, or something like a regular CI/CD pipeline like GitLab or Jenkins. Anything that can talk to Kubernetes can apply this YAML for you and automate this even further. So again, if you're not into Kubernetes, this might take a little bit to make sense of, but it explains in the lab very clearly about what these pieces are and how to do that. So once your developers or your automation team or whoever's going to create your Tanzu Kubernetes grid clusters for you creates a cluster, then what's going to happen is now it's time for your development teams to go ahead and start deploying their applications and accessing these clusters. So this section of the lab will take you through logging into the Tanzu Kubernetes grid cluster. So if you remember, we already did a vSphere login where we were just logging in to see what namespaces we had access to. And it showed us our list of namespaces that we could access and create clusters in. Once you create a cluster, what you want to do is actually be able to log into that cluster itself. And so we use the same Tanzu Kubernetes grid or kubectl vSphere login, but we add a couple additional pieces on here. We add the name of the Tanzu Kubernetes grid cluster that we want to log into. So again, your developers are going to be deploying applications on these TKG clusters. And so they just say, hey, I want to log into this TKG cluster 1. They can find out the names of their cluster by using some of those other commands I showed you earlier. And that cluster happens to be in this namespace. So when they issue this command and then they go ahead and log in, what happens is they'll get that list of context specs, but you'll notice that they also have the TKG cluster context. And so what you can do is on the next page, it would have you go ahead and show you the command to change again the context of your kubectl to use this context. And again, this is just changing the focus of where your kubectl is going to try to execute commands again. So now it's going to be talking to the Kubernetes API on this TKG cluster instead of trying to talk to the Kubernetes API on your supervisor cluster. And then you'd be able to do things like get nodes or get pods or get namespaces and deploy applications. And so what you notice here about a Tkg cluster is, again, it's a fully formed Kubernetes cluster. It has its own control plane, its own set of workers. These are running on virtual machines that we were looking at a few minutes ago back in vCenter. And so your developers can do anything they could do on any upstream cluster. They can create custom roles, they can create config maps, they can create service accounts, they can do all those types of things and deploy their applications. So the next step of this lab, we'll also talk about deploying a couple of applications. So first of all, it'll go through and have you deploy Nginx, which is a stateless app, so it doesn't have persistent disk. It just deploys the application and takes you through that, so you can work through that on your own. And then there's a second part, asks you to show how to get to it through the web browser. One of the things I do want to point out is, again, since we have either NSX or HA proxy or Avi behind the scenes here, is when we deploy an application and expose it as service as type load balancer, we will automatically provision a routable public or a routable IP within your org for this particular application. And so the screenshot shows you how you would go through and find the IP address that Nginx is listening on. And again, we're providing this as part of that network service where we allow you to consume the networking that we have configured to automatically service this. So you don't have to go to your admins and request an F5 VIP or anything like that. We will automatically give you a VIP for anything you expose externally using service of type load balancer. And so this part will take you through figuring out what that IP is, testing out Nginx in the browser. And then we also go through and deploy a stateful app, which uses disks. So it has state and has its own PVCs, and it talks about how that happens. And so you can work through this. Now, I'm not going to do these in this lab because we're running short on time and I want to make sure we leave time for questions. But these are the parts of the labs that you can work through on your own service or your own time, deploying microservices and applications, logging in and validating those jump box items, all of that, things like that. So basically you can do this in your own time. And there's a number of cool apps that you can deploy here that kind of build upon each other. Another thing you can do if you want to is to go ahead and actually deploy another Tkg cluster. I have to make sure I can get into the right space here. So we have this Tkg cluster file that we talked about earlier. That is the YAML file to deploy a cluster. And so if you wanted to edit this, you could actually edit this. And what you would need to do is change the cluster name to something different than Tkg cluster 01. So you would just want to do maybe cluster 02, for example. And again, since these labs are live, you can do this anything you want. And then maybe change the worker count from 1 to, or from 3 to maybe like 1. So you have one control plane worker count, change the cluster name to cluster 02, save the file, and then do a kubectl apply -f on the file name. And it would actually deploy another cluster for you. So you can actually see how that actually works real time. And that'd be something I suggest you do as well. And then the last part of the app does talk, lab does talk a little bit about Harbor. So you will find up here a saved link to Harbor, which is, that's a upstream open source container registry that you can run. It also is part of the Tanzu portfolio. So it will tell you how to log into that. You can check that out. And then it will also talk a little bit about, I believe, Octant, which is an upstream open source free product that VMware has that basically allows you to dig into the cluster and look at what's going on. So it'll show you what's going on with the deployments and the applications and allow you to really dig into it. It's kind of like a Kubernetes dashboard on steroids. So with that, we'll go ahead and wrap up the lab and leave some time for questions. I appreciate you guys hanging in with us. I know we moved through a lot of it very quickly, but go back and play with the lab in your own time and experience all of this stuff. So questions we got.
Excellent presentation, really cool demo, Bob. Thank you so much for sharing that with us. We do have a ton of questions out here, and we just have a few minutes left probably to handle some of these questions. I'm looking down the list here, and there's a lot of great questions. I do want to remind everyone before we go and wrap up, don't forget about the Handouts tab as well. You can follow along and do everything there that Bob walked you through with the first link that's at the top of the Handouts. Follow along with vSphere with Tanzu. There's also the lab guide in there, as well as the resource on VMware vSphere 7 with Kubernetes. So the first question, Bob, I see here on the list, they're asking, is there a specific version of Kubernetes that's supported with this? And is there a required version of vSphere that needs to be used?
Yeah, thanks, Dave. So this is based on what we looked in the hands-on lab today. It is vSphere 7 that has the built-in Kubernetes functionality that we looked at in the lab. 7.0, so 7 update 2A is the latest. That added in support for Avi and a couple other pieces instead of HA proxy. And then if we talk about the Kubernetes version itself, so as we saw in that content library, we ship a number of different versions of Kubernetes, 1.20, 1.18, 19, 17, 16. So we support a wide number of versions of Kubernetes, but it is all Tanzu Kubernetes Grid, which is VMware's signed binaries. It's not a fork of the upstream project. It's actually the upstream binaries. We take it, we sign it, we put our operators in, and then we support it. And we're very active in upstream. So we work with upstream. When we patch something that they have not patched, we can submit that upstream. If they patch something, we can pull it down and wrap it in. So it is all Tanzu Kubernetes Grid that's supported as terms of what distribution of Kubernetes, but that is upstream compliant Kubernetes that's delivered. So hopefully that answers the question. There is a multi-cloud version that will also run on 6.7. We'll cover that here, but that's there as well.
Okay, excellent. And that kind of brings us here to the next question. They're asking, what clouds could we run this on? And specifically, they're asking if GCP is on the roadmap for the future.
Yeah, GCP is definitely on the roadmap. Our Tanzu Kubernetes Grid integrated Tkg, which some of you may have known from the old days, is called PKS. That does still run on GCP, but we're working on getting our multi-cloud product in there. I don't have, I can't give out exact timelines, but it is definitely roadmap.
Got it. Okay. And then kind of a high level question here. What's the benefit of VMware Tanzu for the company? I mean, I think most everyone's familiar with VMware vSphere, but specifically VMware with Tanzu, what's new or what's different? What do people need to know?
Yeah, I think one of the main things that I really look at is, we talked about, I think at the beginning, Tanzu is a portfolio. So there's service mesh, there's a global fleet management piece of it, there's the build service piece of it, and those types of things. But if we talk about Tanzu Kubernetes Grid, which we looked at here as part of vSphere 7, the first thing is that it's built in. So you don't have to stand up a different product. You basically enable this product. Yes, you do have to stand up something like Avi or HA proxy or NSX for the networking side, but essentially it's built in and it leverages the things you already do. So you already have the vSphere platform that you're running VMs on. You can use that same platform now to provide, Kubernetes as a service to your teams. And it uses the storage that's already there. If you're using the standard networking, the networking that's already there with the addition of, having to add Avi or HA proxy as another appliance. And so it's all kind of part of what you're already used to. Also, since we leverage the SSO components in there, authentication is easier. You don't have to stand up a third-party product to do that. And so you kind of have a single platform that you can run it all. You don't have to do any provisioning of virtual machines to stand up your clusters. A lot of products, you need to feed it a set of pre-provisioned virtual machines that you have to then, set up and manage first, where this is all kind of built in. So once you turn it on, you're basically able to really just leverage that service and really, really push out Kubernetes clusters with ease on what you've already got.
Excellent. Excellent. Well, we got a lot of questions still left here. I'm afraid we're going to have to get back to those electronically since we're running out of time here in our live webinar event. But Bob, I guess before we go, just kind of final question. I mean, for folks who want to get started with this and try it out. They just go to the hands-on lab link that's there in the Handouts tab. And then kind of what happens after that? It's a quick free registration, I believe, and then they can gain access to this lab.
Yeah, right. Hands-on labs are definitely free. So you can just basically go to the hands-on lab catalog and search for the HOL 2113. Go through it as many times as you want, and it will give you a good feel for how the product integrates. The other thing is you can kind of go off script. So, we definitely have a lab manual that lets, kind of works you through the stuff. But once you've done that, you can go ahead and create your own namespace and try, play around a little bit. There's some deployments in there to deploy the apps. So it will definitely give you a good feel for what's going on.
Excellent. All right, Bob. Well, it's been really great having you on. Thank you so much for sharing all your knowledge with us about the new vSphere with Tanzu.
For sure. Thanks for having me, and I appreciate everybody's questions. I'll continue to work through the questions that were asked on the chat and see if I can get them all answered, but definitely appreciate you guys having me and your time and interest.
Absolutely. And thank you to VMware, of course, for supporting the event today. Check out, again, the VMware Hands-On Labs, the lab guide, and there is the download right there on VMware vSphere 7 with Kubernetes. You can go try this out for free in the VMware Hands-On Labs and gain some experience, see how this can help you at your company. This is the first of a 3-part webinar series we're doing here with VMware. So we hope to see you on our upcoming events in this series. Watch your email inbox for invitations to the other upcoming webinars here in the series. And with that, I want to announce the winner of our Amazon $300 gift card. This is going to Jeff Obranovich from Tennessee. Congratulations, Jeff Obranovich from Tennessee. We'll reach out to you to deliver your gift card, and we'll also be reaching out to our best question prize winner as well. Thank you to everyone who joined us today on the webinar. I hope you learned a lot and have a great day. We'll see you next time. Bye-bye.